Hey guys, today we're going to continue our talking about polynomials. We'll work into some equations. Feel free to pause as you're going when you're watching the video, and always you can email me if you have questions. Before we get started with the equations though, we have a little problem I want to try together of finding the area of the red section. So if you're using the slides, this is the first slide. So let's get rid of this. Oh yes, I've upgraded my eraser using a hockey puck. We'll leave that right there, just to remember. Alright, so in the problem that we have, there is a blue rectangle inside a red rectangle, and our goal is to find the area of the red section. So to do this, we need to find the area of the red rectangle and subtract the blue rectangle. So the red rectangle, if you're finding the area, we should know that's length times width. And for the red, that would be 12y cubed. That's your width times your length. And here's your length. And in order to find the area of just the red, that would be the whole red rectangle, we're going to need to subtract the area of the blue rectangle, which would be 2y squared times the quantity x cubed y plus 4y. Have a double parentheses there. So the area of the red rectangle, when you multiply, you're going to end up with 36 x to the third y to the third. Then when you multiply again, you'll have plus 12 x y to the fourth, and then plus 24, and we'll have just y cubed. Now when you simplify your blue over here, you're going to be doing, well, we can write this as, if we take the parentheses away here, we're kind of like distributing a negative 2y squared. So negative 2, and then x to the third, y to the third, and then minus 8 and y cubed. So this is what we're subtracting. And when we go ahead and simplify, look for your like terms. So we're looking for x cubed, y cubed. So we have 36 of them. None here, none here. We have minus 2 of them. So we're going to end up with, combining these two, 34 x cubed, y cubed. Now we're looking for any x, y to the fourths. There's 12 of them here, and that's all we have. So we still have plus 12x, y to the fourth. Now next we're looking for any y cubes. We have 24, and we're subtracting 8 away. So we're going to have plus 16y cubes, and this would represent the area of the red section of the figure that we have. Okay, let's move on to some equations involving our polynomials. So if we go to the next slide, there's 3 equations. We'll go one at a time. Start off with that red one in the top left. So here we have the equation t times the quantity 2t plus 3 plus 20 is equal to 2t times the quantity t minus 3. Now in order to solve this equation, we need to simplify both sides. So even though we have like monomial times a binomial here, just like you have in the past, you want to simplify both sides of the equation first and then start moving things around. So you can go ahead and distribute. You should end up with 2t squared plus 3t. And we're not going to distribute the t to the 20. The 20 is not in the parentheses, so the 20 stays. Then over here you're going to have 2t squared and then minus 6t. Now look at the left side, you are completely simplified. The right side is completely simplified, so you can start moving things to both sides. You're going to notice if you subtract 2t squared from both sides, they're both going to go away. And now we can get all of our t's to one side. They're not going to cancel out here. Bring our 20 down. So 20 is equal to negative 9t. Divide by your negative 9, so t is equal to negative 29ths. So our final solution to this equation is negative 20 over 9. On to our second equation. Our second equation, this is the green one. We have the d times the quantity d plus 3 minus d times the quantity d minus 4, and that's equal to 9d minus 16. So again, make sure you simplify both sides. You might notice the right side is already simplified, which is nice. But we have to do a little work here on the left. D squared plus 3d. You're distributing a negative d in here. So you'll have negative d squared plus 4d. That's equal to 9d minus 16. Combine like terms. D squared minus d squared, those cancel. 3d plus 4d is 7d. Equals 9d minus 16. Get all of your d's to the same side. 9d minus 9d. So you have negative 2d equals negative 16. Divide by your negative 2, so d should equal 8. So your solution set here is 8. And on to our last one. On this slide, we have the equation 2x times the quantity x plus 4 plus 7, and that equals x plus 8 plus 2x times the quantity x plus 1 plus 12. So we need to simplify both sides. And there's a lot going on here, but just go one step at a time and you'll be fine. So distribute your 2x. You have 2x squared plus 8x plus 7, and we are completely simplified, all like terms combined. Here we still have x plus 8, then we have plus 2x squared plus 2x, and then plus 12. We need to simplify over here. On our left side though, everything, all like terms are combined. So let's take our x's. We should have 3x, our 2x squared, and you could put that 2x squared out in front if you want to help stay organized. That would not be a bad idea. 8 plus 12 is going to give you plus 20. Now if you look, you can subtract 2x squared from both sides, and you're going to see that they cancel out. And now we can get all of our x's to one side, so minus 3x minus 3x. You'll have 5x plus 7 is equal to 20. And now just get your 7 over here. So 5x is equal to 13. And then divide by your 5, and you've isolated x. So your solution set would be just containing 13/5. One thing you might notice with all of these, our x squareds have canceled out in all of these, and that's because when they don't cancel out, there's some special things we need to do to solve those equations. So right now we should be expecting the x squareds to cancel out, and we'll address how to solve it when they don't cancel out in the future. We need to build up some other skills first before we solve those equations. Those are called quadratic equations. Alright, now if we go to the next slide on the presentation, I think this is a good time for a team captain to take over the problem. So go ahead and try this one on your own. If you feel up to it, make a little video, email it to me, and I'll post some of the better videos with the correct solutions so everyone can use those as reference. Time for the team captains.